Hello everybody, today we'll be demonstrating our group's truss analysis program. This is a very powerful tool for mechanical, civil engineers, or really any application where trusses are involved. Um, the this program is that allows the user to input members, joints, external loads, and supports, and the computer will analyze the truss and provide the user with various information about it. This is a useful tool for allowing the user to get a feel for their truss before entering the modeling and final design stage. So I'll begin my demo by just running the program, which is written in Python, so I'll use Python 3 as the main.py is the name of the file. So once we run it, we are immediately greeted with the header, and the first prompt is for the number of joints. So we have 4 joints. I'm going to be using this truss that's on the bottom of the screen here. So we have 4 joints, A, B, C, and D. So for joint 1, I'm going to use joint A, and its coordinates are 0, 0. And it's going to be supported by a pin support. So we're going to enter 1 here. The horizontal load on this joint is going to be 0, as well as the vertical load. This is the external load that's asking about. There's some error checking right there for you. At joint 2, which is going to be B, this is going to be at 5 and 3. This has no support, so it's going to be 0. It's going to have no horizontal load, and it's going to have a vertical load of 40 newtons. So we're going to input that. Joint 3 is C at 10, 0. This is going to be a roller support, so 2. No horizontal load and no vertical load. And joint 4 is going to be D at 5, 0. No supports and no external loads. So now we're going to move on to inputting the members, of which we have 5. So we're going to tell that. The first joint. So the way it asks about the members is it goes through the members and asks which joints they're connected to. So member 1, of course, is connected to A and B. So remember, in the program, joint A is stored as joint 1. So we're going to do 1 and 2. So that is now stored in the computer. So now we have member 2, which goes from B to C, so that's 2 to 3. And member 3 goes from C to D, so 3 to 4. And 4 is 4 to 1, and then 2 to 4. So now that we have all that information inputted into the program, it gives us the opportunity to save the truss. So I'm going to save it as trusty truss. And now we have our menu with various options here. So our first one, as you can see, is to display the truss. It's the display command. So I use D for that, and that immediately gives us a drawing of a quick diagram of the truss. Very simple, very straightforward. We have our members, our joints, and here this gray line is our external load of 40 newtons. Once you close that, we can use the view command, which gives us all the really useful information about the truss. As you can see, we have our 40 newton or 40 ounce load up here. We have our internal forces on the members. So member 1 and 2 will have 38.87 newtons, each of them. And the C represents compression, and members 4 and 3 will have 33.3 newtons, and this represents tension. And member 5 is a zero force member, which for those of you who have taken any sort of truss analysis class or know anything about analyzing trusses, that makes total sense. This is, in fact, a zero force member, so this is all working properly. And we get our reaction forces. So the reaction force at the pin support of A in the x direction is in fact going to be 0, and that's because there are no external forces in the x direction. And then the external forces in the y direction are going to be 20 each, and that's because the force here is evenly distributed due to the fact that these members are equal length. So now we get our cost of truss and load to cost ratio, and that's just calculated with data from our statics class that we took, and it's basically just a multiplier times the total length of the members. Now we go into our other functions here. We can delete this zero force member using the command N to delete a number. This is very simple. We just type 5. This is the ID of the number, and just like that, it is gone. If we use the display command, you can see there's no longer that middle zero force member there. And if we wanted to, we could get rid of this joint here as well. So let's try doing that real quick. We're going to use H. That's joint 4. And just like that, the joint has been deleted, as you can see. And now if you want to add that joint back, we use J. It's the same process as before. We have our X coordinate, Y coordinate. It has 0 supports because it's joint D that we're doing, and 0 external forces. And if we look at that, now we have that joint is back. And to add that member, we use M, and it's going to be from 2 to 4, of course.